Hello and welcome to my channel. I am Augustine, and I'm going to show you how to find the largest possible domain of a rational function that contains a radical or square root at the denominator. Now let us look at the question that we have. A function f of x is defined by f of x is equal to 7x minus 2 divided by square root of x squared minus 9, where x is a subset of real numbers. How do we find the largest possible domain of this function? We will find the largest possible domain and then also represent it using interval notation. Now, since the function is of the form a divided by b, we will look at the numerator and then look at the denominator. So if we take the numerator, we have 7x minus 2, and it is what? A linear function. So here, this function is defined for all real values of x, since it is linear. Now, let us take the denominator. We have square root of x squared minus 9. We know that square root of negative numbers are called complex numbers. So this function is defined if and only if x squared minus 9 is greater than or equal to 0. Because if this expression, that is the expression under the square root, is greater than 0, we are going to get square root of positive numbers, and square root of positive numbers are subset of real numbers. If the expression under the square root is also equal to 0, we are going to have square root of 0, and square root of 0 is 0. 0 is also a subset of real numbers. Now, let us consider the whole function. Since the whole function is in the form a divided by b, if we put b equal to 0, we are going to have a divided by 0. And here, the function will become undefined. So, when we come here, since the radical is a denominator, it means that the expression under the radical should not be equal to 0. If it is equal to 0, we are going to have 7x minus 2 divided by square root of 0, which will give us 7x minus 2 divided by 0, and the function will be undefined. So here, what should we write? We are going to take x squared minus 9 greater than 0. This will be the domain of the rational function. So let us solve this quadratic inequality. Now, we are going to have x squared minus 9. Let us forget about the inequality sign first and then equate it to 0. We are going to have x squared equal to positive 9. Square root of x squared is equal to plus or minus square root of positive 9. And x equal to plus or minus 3. So we are going to have x equal to positive 3, x equal to negative 3. Now, let us represent the roots of this quadratic inequality on the number line. On the number line, we have negative 3 here and positive 3 here. Now, we are going to test the values within this interval, that is negative 3 to positive 3, and see if they will satisfy this inequality. Now, the best value to choose is 0 if 0 falls within the interval, and here 0 falls within the interval. So we are going to consider 0. Now, if we consider x equal to 0, we are going to have 0 squared minus 9, which is equal to negative 9. And negative 9 is less than 0. It means that if we put any value between negative 3 and positive 3 into the inequality here, it will not satisfy the inequality. So if we stand on negative 3, we will take numbers to the left. And if we stand on positive 3, we will take numbers to the right. Very simple as that. And why are we using these open brackets? Sorry, open circles. We are using the open circles to show that the endpoints are not included. Now, we are going to set the domain as x is such that x is less than negative 3 or x is greater than positive 3. Why are we using less than? Because numbers to the left of negative 3 are less than negative 3. And you're using greater than because numbers to the right of positive 3 are greater than positive 3. Now we are going to represent x less than negative 3 and x greater than positive 3 using interval notation. Now for interval notation, we know that we use the parenthesis brackets to show that the endpoints are not included, and we use the rectangular brackets to show that the endpoints are included. So here, since negative 3 is not included, we will use the parenthesis brackets. And here too, since positive 3 is not included, we use the parenthesis bracket. Now, numbers less than negative 3 will move up to negative infinity. So we are going to have negative infinity to negative 3, where the parenthesis bracket shows that the endpoints are not included. And then we are going to have positive 3 to positive infinity, because numbers that are greater than positive 3 will go up to infinity. So now let us write the domain using the interval notation. We are going to have negative infinity to negative 3 union positive 3 to positive infinity. You can also check the description on the video for how to find the largest possible domain for functions containing radicals. Now, if you have any question related to this, leave it at the comment section. If you have any other mathematics problem that is troubling you, leave it at the comment section and I'll be of help to you. Bye bye.